Hey guys, this video is to go over some practice with Lesson 1 in Algebra 2 Unit 1. Algebra 2 Unit 1, our unit is based on functions, and Lesson 1 is specifically based on relations and functions. And the first objective that we were going to deal with, or the first lesson, is the goal of identify whether or not a relation is a function, okay? So we're going to dive right in and try some examples together. So these are questions that you should be able to do after the notes were taken, after the examples were done in class, after any discussion, and you should be really comfortable with this sort of exercise at this point. Here it's asking you to determine whether or not the given relation is a function and to justify your answer. If you want a lesson on this, this is just accompanying the lesson that we did. The lesson has a separate video. I'm just going through the answers as a way for you to check your work, okay? So if you need more support, please check the other video. Now, is this relation a function? Well, if a relation is a function, we won't repeat our x values, so the answer is yes. And to justify your answer, okay, to justify the answer, no x value goes to more than one y value. So no x value corresponds to more than one y value. Okay, so I'm not going to go into too much description moving forward. I might not write it. I might just say it out loud. So if you don't have the sound on, you won't hear. I'm sorry. Determine whether or not the given relation is a function. 2, boom, there it is. We already used the same x value twice, so no. Okay, I'm showing why. That's the reason right there. Got it. Next, we have -8, -8. Well, there we go again, right there. Okay? No. So you might want to write not a function, so I know what you're saying no to. Okay? Not a function. Okay? Next. This is a mapping diagram. Because this B is going in two different directions, the answer is no. Okay? Not a function. Done. Next. Very nice. Yes. This is a function. If you're having trouble with something like this, you really should have been in for extra help probably a week ago. So I hope everyone is doing great. Here we have a table of values. If you look, I have -6 twice. I have 5, or -5 rather, twice. I have -4 twice. Not a function. That's it. We're done. That's how simple these questions were. Okay? Right here. Right there, again, repeat offender. -15 goes to -15 and -7. That is why. Okay? This is fine. This is not fine. Not a function. Next, I have a graph. My relation is represented by a graph. Really, there should be arrows at the end, but the image I cropped it from didn't have those arrows. We have the sideways parabola. How do you determine from a graph if it's a function? You draw in a vertical line. Okay? Fails the vertical, please spell vertical correctly, vertical line test. Not a function. Okay? Done. You're going to have to prove in life that you could spell vertical correctly, so you could write it out one time. After that, you could abbreviate vertical line test, like we'll do right here. Not a function. Fails vertical line test, okay? Please show me that you could spell vertical once and then abbreviate after that. Here, we have a linear function. Well, you'll start calling them linear functions and not linear equations because now you know that essentially every line is a function. The only line that's not a function is a vertical line because obviously a vertical line fails the vertical line test. Yes, this is a function. I'm justifying it by talking to you or drawing little things on here. If it were a test or a quiz, make sure you give a little bit more information than that, but I think you should be able to. Now, this part, this is to get us ready for the next section. This is just an inequality, and we're really focused on writing an interval notation to get us ready for domain, okay? So if I were solving this, first and foremost, I would expect you to rewrite the question. That is really important. Stop trying to squeeze it over there. I'm not trying to grade your work when you squeeze half a step there and then write an answer, especially when that answer is wrong, but also when it's correct. Show me work. It's the beginning of the school year. It's the beginning of a new unit, beginning of a new class. You have to prove yourself before you start trying to show any shortcuts on your paper, okay? You need to go above and beyond. You need to be an overachiever. X is less than or equal to 9. If I draw my number line like it asks me to do, graph the solution set on a number line, you have to do that. This is colored in, closed, and that's 9. Less than or equal to 9 gets us to have this right over there. Interval notation that corresponds is going to be negative infinity, comma, 9 with a bracket. That's all there. Oops, sorry if you're a little cut off there, sorry. Okay, so that is all there is to it. Next example. We have 1.5 more steps, but we should be okay with this. So negative 2 times 2x minus 5 plus 2 is greater than 4. I'm going to distribute negative 4x plus 10. I'm also bringing over the 2 at the same time, so I'm going to subtract 2 from both sides. That gives me a 2 over here. I'm going to subtract the 10. Maybe you did it in a different order. Totally fine, as long as it's valid, as long as it's legal math. Negative 4x is greater than negative 8. Now I'm going to divide because negative 4 is attached with multiplication. From Algebra 1, you should remember when you divide both sides of an inequality or multiply by a negative number, you must turn your inequality symbol around. So that leaves me with x is less than 2. Now why is this the case? Side lesson, okay? If I have negative 4x is greater than negative 8, if I add 4x to this side, I'm going to add it over. I'm left with 0, right? I have a negative 8 and a positive 4x. Now I'm going to add 8 to this side, plus 8 plus 8. I have 8 greater than 4x. Now I'll divide by 4, x, 4, so, 2. So some of you might read this as 2 is greater than x. I've been telling you, read from the x. X is less than 2. X is less than 2. So that negative turns everything around for us. So please remember to do that. Now, that's just our inequality answer. Okay, that's one part of it. Now, the number line. We don't need to go crazy. Don't take all day. Here's 2. Boom, open circle. Less than 2. I'm going to shade this way. Interval notation will be from negative infinity, comma 2 with a parenthesis because the 2 is not included. It is open. We get very, very close to 2. In fact, we get infinitely close to 2, as close as one can get without actually getting there. This guy is called a compound inequality, and to work it out, you must get your variable alone in the middle. Please start crossing your z's in the middle because so many people keep calling this 2 when I call on you in class to talk about this problem. 2 is less than 12 minus 2z, which is less than or equal to 6. So really, this amount, this quantity, is less than or equal to 6, but it's greater than 2. This thing we can say is between 2 and 6, with 6 included. These are ways to describe what's happening. Try to find ways to articulate the math you are working on. I'm going to subtract 12. I'm trying to get z alone, but I must subtract 12 from all 3 places. Okay, this is an Algebra 1 problem here. I have negative 10 is less than negative 2z, which is less than or equal to negative 6. Here's a division by a negative again. All of the inequality signs are going to reverse, but it's not that this one goes there and this one goes there. They turn around where they are, okay? Then negative 2 down there. Division, I get 5. Flip it, greater than z, greater than or equal to 3. Now, number line. My smaller of the 2 numbers is 3, the bigger is 5. 3 is with the or equals to, so I color that in. 5 is open. Now from the z is greater than or equal to 3, we go this way, but z is less than 5, so we go this way. So it's the space in between. This compound inequality, this guy qualifies as an and inequality. I have to be less than 5, and I have to be greater than 3. Sure, less than 5 goes this way forever. Sure, greater than 3 goes this way forever, but it's an and, so I need where they overlap, which is this region right here. So here's my inequality. Here is my number line. Really, the solution is the one in the middle. And now my interval notation, bracket 3 until 5, not including the 5, including 3. I don't know if I cut it off a little, I'm sorry. And that's it right there. Next, 4x plus 10 greater than 34, subtracting 10. So 4x is greater than 24. Divide by 4. X is greater than 6. There's my inequality. Number line. Here's 6. Open because it's not or equal to. And I have this right over here. Okay. There shouldn't be a mystery as to whether or not your circle here is going to be colored in. I shouldn't have to guess. Okay. Make it clear. And then I go 6 until infinity and we're done. There's our 3 parts to the answer of the question and third part. Absolute value inequality comes next. I'm going to start by dividing by 6. We want to, what we said in class, we want to isolate our absolute value sign. This whole section needs to be alone. So divide by 6. Oops, that's supposed to be 12. And divide by 6. So the absolute value of x plus 10 is greater than or equal to 2. Now, I have the absolute value of something. We're using our imagination for a moment. Now, whatever's in here has to be greater than or equal to 2. Whatever's inside has to be greater than or equal to 2. However, if I'm going to take the absolute value of it anyway, it might be negative. What type of negative thing can go in here? Negative 2 can go in there, so that's actually pretty good. So the or equals could be including it. Now, which way should I go? If I go to negative 3, if the inside equals negative 3, I'm going to take the absolute value, I get positive 3. Is positive 3 greater than or equal to 2? Yes, so that means whatever's inside can be less than or equal to negative 2. Same inequality sign, same number. Change the inequality sign, change the number. So whatever's in here happens to be an algebraic expression because, well, we're in algebra 2 now. X plus 10 can be greater than or equal to 2. X plus 10 can be less than or equal to negative 2. Then what we do is we solve both of these inequalities. So I'm going to start off by subtracting 10 from both sides on really both of them. I keep mentioning in class for us to do this side by side. Don't stack them so your work can go underneath, okay? X is greater than or equal to negative 8. X is less than or equal to negative 12. Here is my number line. 2 tick marks I'm going to have. Negative 12 and negative 8. They're both the same. They include the point. Greater than or equal to negative 8 will put us this way. Less than or equal to negative 12 will put us this way. This is actually an or inequality. It can be this or it can be that. So one or the other. Ooh, where am I going? I said or and I started doing this. I'm not paying attention. Sorry. So this is an or inequality. So I'm going to go this way as a solution area that I can pick from, kind of like what we'll talk about in domain. It's sort of your options, the numbers you can use, the numbers that can satisfy the equation. So I can go this way or this way. You have to remember how to do these, okay? Interval notation, negative infinity, that's what this is, okay? Negative infinity. We have to remember how to do this. This is negative infinity on this end, and this is positive infinity on this end. So negative infinity until negative 12 with a bracket colored in, closed, included, union. Then from negative 8 until infinity. So what do I have here? I have my compound inequality solutions, which I can put the word or in between. I have my number line, and I have my interval notation, okay? So I'm just going to circle each of these, right? And this one right over there. Now we go to the next part, which I added some questions onto. There were some mistakes I had on there, so I did fix them for you in class. Hopefully I remember what I wanted them to say. So this, same direction, solve the given inequality by hand. I'm not kidding when I say I want to see work, okay? Some of you seem to think you're going to challenge me on this. So please, I'm begging you, show your work. I don't want you to make a careless mistake, and then I can't give you any points if I don't see your work, okay? Please, in the beginning of the course, always go above and beyond. I can't say it enough times. So I'm going to add 9 to both sides. I'm trying to isolate the x, similar to how we isolated the absolute value. That gives me 4x is greater than or equal to 20. Again, it's greater than and less than, not then. Then means next, okay? greater than or less than with an A, okay? It's math class, you want an A in math class. Divide by 4x is greater than or equal to 5. Here's my inequality. Show or graph the solution set on a number line. Here we go. Number line, there's 5. Greater than or equal puts me in this type of a situation. Write the final solution set in interval notation, bracket 5 till infinity. Down here, what is the smallest integer in the solution set? You should have written down notes on what an integer is. So the smallest integer is 5. Okay, the next question. I did change 17 to the smallest. Instead of integer, I asked you to change this to say the smallest whole number. So make sure you did that. If not, you missed the memo. Same instructions, solve by hand, show all work. Graph the solution set on a number line, write the solution set in interval notation, and then we'll answer this question. Distribute, I get 3 times 6, well, let me write it out, because even I, who does math all day, every day, show my work. Distribute, I get 18x minus 24 minus 2. Last time I brought that number over first, this time I'm going to leave it, just for a little variety. This is now 18x minus 26 is less than or equal to 10. Add that 26, 18x is less than or equal to 36, divide by 18, and I get x is less than or equal to 2. That's my inequality. Where's my number line? Here's 2, or equal to, less than, goes this way. There's my number line. Where's my interval notation from negative infinity until, what is that, positive? Yeah, positive 2. Sorry, it's a little wonky looking. And included, there's my interval notation. Now, what's my smallest whole number in the solution set? If you don't know what the whole numbers are, how are you supposed to answer this question? Whole numbers, the middle of the word whole looks like a 0. Whole number start at 0, 0, 1, 2, dot, dot, dot. So what's the smallest number in whole number in here? Well, it's 0. Done. Next, number 18. We have another compound inequality. We have a z in the middle. I do see a negative. I know I'm going to have to do some flipping. So I have 12 is less than or equal to 8 minus 4z, cross your z, which is less than 16. So this value of 8 minus 4z, whatever this value represents, is less than 16, but it's greater than or equal to 12. It's between them. Now I'm going to isolate the z in the middle. I'm going to do it all at once. Could you break it up into 2 different inequalities? Sure, knock yourself out, but not really necessary, okay? We could just leave it all together. Divide by negative 4. Again, you multiply or divide both sides of an inequality by a negative number. You flip your signs in their place, okay? So then that's z, and now it's greater and negative 2. Also, in a compound inequality, your arrows on the inequality part of it should both be pointing in the same direction. Here, both left, both left, both left, both right. However, when you go to shade, when you read from the z, they should be pointing in opposite directions. So z is greater than negative 2, but z is less than or equal to negative 1. So number line, here's negative 2 and negative 1. The negative 2, I have an open circle. The negative 1, I have a closed circle. Greater than negative 2 puts me this way. Less than negative 1 puts me this way. So I'm right over here, and interval notation, negative 2 until negative 1 with a bracket. Now, ooh, I'm so sorry. I'm definitely cut off. There it is. Okay. Now, what is the smallest integer in the solution set? Integers include positive, negative, 0, nice whole numbers, but they include the negatives. What's the smallest integer in here? Negative 2 is not in the solution set. The smallest integer will be negative 1. Okay? The end of that one. 2 more questions, okay? We have 9x plus 15. I did change this question too. I believe I asked us to write down the word largest instead, okay? Here, 9x plus 15 less than, oops, not or equal to, I don't know where I got that from, is less than 60. I'm going to isolate the x. I'm going to begin by moving that 15. I'm going to take care of the addition or subtraction first. Just kind of do reverse PEMDAS to isolate your variables. That's gone. 9x is less than 45. X then, oops, divide by 9, divide by 9. X is less than 5. This is my inequality. Let's go to my number line. Less than 5. That's where we are. And my inequality notation, or my interval notation, sorry, is negative infinity until 5 with a parenthesis. Because again, it is an open point. It's not included. What is the largest integer in the solution set? 5 is not included. The largest integer is 4. You have to know the definition of an integer or you can't answer these questions, okay? Next. Another absolute value inequality. I have 4, absolute value of x plus 12. Absolute value is really distance between points on a number line. We're talking about how far something is. We're talking about how far some value of x actually is from negative 12, not from 12, because you subtract to find distance. We'll save that conversation for another day, but you definitely did that in Algebra 1. Divide by 4. I have the absolute value of x plus 12 is greater than 6. Now, you have to remember, you have 2 lines on your absolute value. You get 2 equations to come out of here, okay? What are your 2 equations? The first one, you write down what's inside of the absolute value bars. Same sign, same number. Next equation, you write down what's inside of your absolute value bars. Change your sign, change the number on the other side. Boom, that's it, solve. X, subtract 12, subtract 12. X is greater than negative 6, subtract 12, subtract 12. X is less than negative 18. Here's my 2 inequalities. Let's get them on a number line together. Here's negative 18. Here is negative 6. No equals 2, so 2 open circles. X is greater than negative 6. We go that way. X is less than negative 18. We go this way. So I have my inequality and my other inequality. It's this or this. And I have my number line. And last, we'll do our interval notation. I go from negative infinity until negative 18, parenthesis, union, negative 6 with a parenthesis until infinity. What is the smallest integer in the solution set? So really, for this one, I believe we should change it to, because integers are positive and negative, so I shouldn't have written smallest. I'm a little silly. So we could say, what is the smallest? Let's change this to natural number. Do you know what a natural number is? If not, you should have taken better notes, or you should go look at your notes. If you do know, that means you know it means you start at 1. Like, where do you naturally start to count? 1, 2, 3, 4, 5. So what's the smallest natural number? Well, is 1 in here? Yes, somewhere up there, okay, on this side. So the smallest natural number is 1, okay? And that's, oh, and of course, I'm so sorry. I completely cut it off, but I was speaking it, so hopefully we all wrote this down, okay?